All right, a quick question came up on number 9 on practice objective 37. So as you can see, I have something here that is in polar, which means it's in r and theta, and I would really like it if it was in x and y. So that's my job to convert it. Well, the problem is we have only some rules that we can work with, right? We have r cosine theta, which is equal to x, and we have r sine theta, which is equal to y. So maybe those would be helpful, but look at that. We got a bunch of tangents and secants. Let's fix them. So tangent we know is sine over cosine, and secant is 1 over cosine. So maybe I would multiply both sides by a cosine real quick. That would at least get one of them out of here, which would be cool. And it would put r cosine theta on the other side. So that's kind of neat, right? If I multiply both sides by cosine, if I multiply this side by a cosine, it's going to go, it's not going to cancel the other one though, right? That one's still there. That's still tangent. But it does put one over here, which that is kind of helpful in the way that this now is r cosine theta. And you're like, oh, sweet, that's x. So now you have this. Now you've really confused people because that you have now created x, have something with x, which is rectangular, and you have stuff with theta that is polar. But why not do something legal like multiply top and bottom by r? Right? That's totally legal in math. Multiplying top and bottom is multiplying by 1, doesn't change anything. So now I have x equals r sine theta, which is y, and I have r cosine theta, which is x on the bottom. Now I can clean it up for anyone to see. So y equals x squared is what they're talking about. That's what this graph would look like. It looks like it's just a parabola sitting at the origin. All right, stay happy.